Okay, so I want to do a little fraction review before you take a quiz and go over some of the things that we have learned about fractions. And I don't want to make this a really long video because I know it's difficult to pay attention for a length of time. So I'm going to try to go over each of these concepts pretty quickly. Okay, so first thing that we learned about, or one of the first things, were equivalent fractions. And equivalent fractions are fractions that name the same part of a whole. And we learned that we could find equivalent fractions by using fraction strips, for one thing. You could use fraction strips. So if this is a whole, then this 4/4 represents that same whole. And we can use that fraction strip to see that 1/2 is equivalent to 2/4. And 1/2 is also equivalent to 3/6. They name the same part, okay? And it's also equivalent to 4/8, okay? So equivalent fractions name the same part of a whole. So I'm going to look at a question here from our textbook, and I'm not sure if we already did this in the textbook. You can go to page 519. We might have done this in another video, but I want to go over it again if we did. So they're talking about how to find equivalent fractions with fraction strips, and they give a whole fraction strip here, and then they have 1, 2, 3, 4, 1/6. So that's 4/6, and 2 1/3, so that's 2/3. So we can tell from these fraction strips that 4/6 is the same as or equal to 2/3. So those are equivalent fractions, 4/6 and 2/3. So I'm going to look at that on mine since I have all my fraction strips out here. Okay, so 4/6 and 4/6 and 2/3. 4/6 and 2/3. They're equivalent. And they have down here, we have two different they're the same whole, but they've shaded different parts. This one, they've broken it up into 1, 2, 3, 4, 5, 6 parts. So each of these unit fractions, that's another word we need to remember, is 1/6. Okay? This one, again, it's the same amount, it's the same whole, but they broke it up into 3 parts, so each of these is 1/3. So by looking at these models, okay, so these were fraction strips, these are area models, we can tell that 2/6 is equal to 1/3. 2/6 is equal to 1/3. So again, if I use my fraction strips, 2/6 is equal to 1/3. Okay? We also used number lines to name fractions, to name where fractions are, and to write equivalent fractions. So let me zoom in a little bit. So here it says, remember that equivalent fractions have different names, but they represent the same point on a number line. I apologize every day for this focus. That's better. Okay, so this number line, they divided into eighths. Each tick mark is 1/8 apart. So 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, and the last one here would be 8/8, which represents one whole. Let me just remind you, 8/8, 8 out of 8, that represents one whole. When you have a numerator and denominator the same, that's one whole. Now here they have it broken up into, and again, to figure out how many pieces they have it broken up, and you don't start there. You go 1, 2, 3, 4, 5, 6. So this is broken up into, or partitioned into 6 equal parts. Partitioned, broken up into 6 equal parts. And so each one is 1/6. This is the unit fraction, 1/6. So we have 1/6, 2/6, 3/6, 3/6, 4/6, 5/6, 6/6. Now I look up here, and they also divided it into what they did here, this 2/8. Here's what they did here. Let's look at these 4s. I see in green here that they wanted to show you equivalent fractions. So they had, here's where their 8s, okay? And then they had this here. So they showed where there was 2/8, that's the same as 1/4. Where there were 4/8, that's the same as 2/4. Where there are 6/8, that's the same as 3/4. And where there are 8/8, that's the same as 4/4. Okay? Now what if we broke this up into just 2 parts? If you broke it into just 2 parts, those 2 parts are called halves. 3/6 is the same or equivalent to 1/2. You see that? So we could also put 1/2. So you can use fraction strips, you can use area models, you can use number lines to show equivalent fractions. And again, they have to be an equal distance apart in order for it to be actually a fraction. That's the important thing when you're showing fractions. Okay, so that was about equivalent fractions. Now, I want to talk about comparing fractions. If I'm comparing fractions that have the same numerator, let me zoom out a little bit. Okay. If they have the same numerator, same top number, so I'm going to put some fractions here that have the same numerator. These all have 1 as a numerator. Okay, so I have 1/1. That means 1 whole broken into just 1 piece. That's a whole. Then I have 1/2 and 1/2. Then I have 4 1/4. Then I have 3 1/3, 8 1/8, 6 1/6. If you have the same numerator, the fraction that has the smallest denominator is actually the biggest fraction, okay? Because you've broken it up into the least amount of parts. So this one is the biggest. If you wanted to make that whole a fraction, 1/1 is the biggest fraction. And then you have a half, so I'll put them in order. Let's say, actually, let's put them in order of least to greatest. So this one, if I was sharing a pizza, I would get a smaller, this would be the smallest piece. I would get 1/8 because I'd have to share with 7 other people. This would be the next smallest. I would get 1/6 because I'd have to share with 5 other people. Then 1/4 would be the next because I would share with 3 other people. But you see how they're getting a little bit bigger when I'm sharing with a smaller number of people. Then I have 1/3. I only have to share with 2 people. 1/2. I only have to share with 1 person. And this, I get to keep it all to myself. So if it has the same numerator, you're looking for the fraction with the smallest denominator. If the denominator is smaller, it's a bigger sized fraction. Okay? Then we compare with fractions with the same denominator. The same denominator. So if I took 2/8, that's going to be 2/8, okay? And I took, I'm talking about denominators. I took 2/8, I almost started cutting up numerators. And there's 1/8, and there's 5/8. Okay, so we have 1/8, 2/8, 5/8. If they have the same denominator, you're just looking for the larger numerator. Okay, so 1/8 is smaller than 5/8, and let's not forget that symbol that confuses people sometimes. If I was comparing these two, 1/8 is smaller than, less than 5/8. Okay, I would do, if I needed to compare these two, I'd have 3/6 and 3/6, same denominator, same denominator. Those are actually equal. Okay, 3/6, 3/6, paper down, equal. Uh-oh, here comes Hulk. I have a broccoli head. I have a broccoli head. Oh my goodness, Hulk, go back. Okay, let me try another one with the same denominator. Hulk is always messing around with me. Okay, same denominator, so let me have this out here. All right, so I have, let me cut this up a little, 1/3, and I'm comparing it with 2/3. They have the same denominator. This one is bigger. 2/3 is 1/3 bigger than 1/3. Okay? So, if you're comparing when they have the same numerator, like these unit fractions, you're looking for the fraction that has the smallest denominator, because that means you broke it up into the least amount of pieces. If you are then comparing with the same denominator, thirds, this 2/3 and 1/3, you're looking for the bigger numerator, for the bigger fraction. Okay, the last thing that we talked about was making, I'm glad I made 2 copies of these now that I used my Sharpie and wrote right through it, making whole numbers into fractions. Okay, so here it's showing with fraction strips. You can use a number line or fraction strips to find a fraction named for 2 using thirds. So here's 1 whole, 1 whole. 3/3 is 1 whole. 3 more thirds is another whole. So 6/3 equals 2. 2 equals 6/3. Okay? The whole number 2 also can be written as a fraction 6/3. So we're going to do some over here because I do have all my fractions that I haven't cut up. What they want me to do here is write an equivalent fraction for each whole number. So they want 3 wholes. Well, let me do this. I don't need a fraction strip. I have these fractions. 1, 2, 3. Well, I could say 3 wholes is the same as 1, 2, 3, 4, 5, 6, 7, 8, 9 thirds. I could say 9 thirds. That's one option. Is that my only option? No, I got all these fractions. Let's see. I got 6. Unless I cut them all up. Okay, I need 3 wholes. That one's cut up. 1, 2, and, oh yay, I didn't cut up this one. 3 wholes, which are broken up into 6 parts. So that'd be 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 6 would also be the same as 3. Okay? 2 wholes. Well, let's do fourths for 2 wholes. 2 wholes is the same as how many fourths? 1, 2, 3, 4, 5, 6, 7, 8. 8 fourths is the same as 2 wholes. 8 fourths is the same as 2 wholes. How many thirds would make 2 wholes? How many thirds? 1, 2, 3, 4, 5, 6. 6 thirds would make 2 wholes. I'm wondering, do I have 5 of, I think I have 5 of the, oh, I do. Let's try halves. 5 equals, 5 wholes equals how many halves? Well, there's 1 whole, there's 2 wholes, 3 wholes, 4 wholes, and 5 wholes. Let me zoom so you can see it. Okay, 5 wholes. How many halves is 5 wholes? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 halves. The total of halves is what the numerator. There were 10 halves. Okay? 1 whole, you could put 2 halves. You could put 4 fourths. You could put 3 thirds. You could put 8 eighths. And what one did I not do? Oh, my 6 sixes. And 6 sixths. All of those stand for 1 whole. Okay, write an equivalent whole number for each fraction. So they have 6 thirds here. 6 thirds. So they have 3 thirds and 3 more thirds. So what whole number is that? 2. We're not going to do that one because I don't have that many. 10 halves. We just did that one. That's 1 2 halves, 3 4 halves, 5 6 halves, 7 8 halves, and 9 10 halves equal 1 2 3 4 5 wholes. 5 wholes. 10 halves, 5 wholes. And last but not least, 8 eighths is the same as 1 whole. 1 2 3 4 5 6 7 eighths. Yay, fractions. I love fractions. All right, that was our fraction review with the Hulk.